Hello, my name is Professor Rad, and today we are going to wrap up our discussion about exponents and radicals by looking at some special terms for certain values. So, sometimes you might hear these words being used to reference certain radicals and exponential expressions. So this first one is squared. Squared means something to the second power. So I have a few illustrations off on the side here. If I want to write 5 squared, that means 5 to the second power. So what's pretty cool is a calculator has a squaring button. So instead of having to use the exponent button, you can take a little shortcut and use the squaring button. And all of my calculators that I have here have the squaring button in the same way. So I'm going to bring in my blue Casio here. And it says to use calculator to find 3.8 squared. So notice this was our exponent button on this calculator, X with a box. Right next to it is an X with a 2. That's your squaring button. So I'm going to type in 3.8, and then I'll press my squaring button, and notice it gives it an exponent of 2. If I press equals, I get 14.44. So for most calculators that have a squaring button, it looks like x squared. So you just have to find your x squared button, and that'll help you get there. Now, a square root is the same as a radical with an index of 2. And a square root is used so often that we tend to write the radical without it. So if you ever see a radical and there isn't an index, there's no number written there, that means it's a square root. That means the index is really a 2. So for example, if I want to write the square root of 36, I'm just going to write a radical with a 36 underneath. Again, radicals or square roots are such a common radical that our calculator is going to have a button for it. So let's check out the square root button. So I'm going to bring back my Casio friend here. And this one has its very own square root button. So to find the square root on here, I'm going to press the square root button. And I'm in line mode, so it tells me the square root symbol and then a parentheses. And we want to find the square root of 961. Close that up and press equals to get 31. Now, this calculator happens to have a square root button, but not all calculators do. So here is our friend, the TI-36X Pro. And here's the, just off screen, I think, yep. Here's the squaring button, the x squared, so that'll do the squaring for us. And notice in blue, just above, is the square root sign. So if I want to find the square root of 961 on here, let's clear out that mess, I'm going to type in second and then x squared. And that types in my square root sign. Then I type in what's underneath, 961, go over, and hit enter. There we go, we get 31. So squaring has to do with an exponent of 2. So if you have squaring or squared, that means your power is 2, or square root means your index is 2. Cubing is when the power or the index is 3. So if I want to cube something, that means something to the third power. Or if I want a cubed root, that means my index is 3. So if I want to write 5 cubed, that means 5 to the third power. And if I want to see the cubed root of 27, that means the 3 is the index for this radical. So instead of saying third root or third power, we might say 5 cubed or the cubed root. Now, some calculators, not all, but some calculators have a cubing and a cubed root button. If I look at this calculator, for example, this is my exponent button, and that is my nth root. Here's my squaring and my square root. Here's my cubing and my cubed root. So for example, if I wanted to find 4.1 cubed, I could type in 4.1 and then press the x cubed button to get it cubed. And that will give me 68.921. I'm just going to do a little arrow here. And then if I want the cubed root of 4913, I'm going to press Shift square root button. And notice now it puts that little 3 in front of the radical to indicate the cubed root. 4913. Close it up and hit equals. And that gave me 17. TI-36X Pro, I believe, does not have a cubing button. I was looking for it earlier and I didn't see it. So either I didn't look hard enough or it just isn't there. So here, if I wanted to find something cubed, I would use my exponent button like normal, or the cubed root, I would use my radical button like normal. So this one doesn't have the cubing or cubed root shortcut, at least that I can see right away. And then lastly, I'm going to bring in my graphing calculator here. And this one does have a cubed root button, but it's hiding. It's hiding over here under math. So if I hit math, option 3 is for cubing and option 4 is for cubed root. So if you wanted to access the shortcut on this calculator, you would have to go to the math menu. So for the cubed root, for example, I would then type in 4, or I could scroll down to 4, and it's going to put that cubed root box there for me, 4913, and hit enter, and it gives us 17. If I want to find 4.1 cubed, 4.1, I can go to math, and this time I'm going to choose option 3 because that's the cubing. Now it put the exponent of 3 there, so if I hit enter, we get our 68.921. What I like about an exponent button, so our exponent button or the nth root button, is that it will find squaring and square roots and cubing and cubed roots for us. So the exponent button and the nth root button on your calculator will do everything. But sometimes when you want a little shortcut, you can use those particular buttons on your calculator. Okay, then I have a couple of theorems to wrap up this video with a now you try of true falses. So theorem 5 says any number to the first power is equal to itself. So if you see a 5 to the first, that's the same thing as 5. So when we get to algebra, it'll be helpful for us to remember that if no exponent is written, it's secretly a 1. Now this is where math secrets are annoying, because when we don't have an index written, it's secretly 2. When we don't have an exponent written, it's secretly 1. So the secrets for exponents and radicals are different, even though they're like connected to each other, which is kind of annoying and weird. Theorem 6 says if an exponential expression has a whole number base and an exponent less than 1, then the answer is going to be smaller than the base. So let's check that out. I'm going to bring back my TI-84 since that's the one that was right next to me. So I want to have a whole number base. Just going to pick one out here like 25. And if the exponent is less than 1, so let's say 0.2, I should get something smaller than 25. Ah, look at that, I did. 1.9. Let's try 25 to the 0.9 power. Still smaller than 25, 18 point something. So if the exponent is smaller than 1, my answer is going to be smaller than the base. If the base is a whole number and the exponent is larger than 1, the answer is going to be larger than the base. So let's try that out again. So let's take 25, and this time let's make an exponent of 6. That is certainly bigger than 25. What happens if we do 25 to the 25th? So we've got 8.8 here, but be very careful. This isn't 8.8. We've got our scientific notation, and that's an exponent for our scientific notation of 34. That means this is a very long number. So be careful when you're doing exponential expressions on your calculator, especially if the exponent is kind of big, because then that means your calculator might be giving it to you in scientific notation. So that, to me, is where Theorem 6 is helpful. I know 25 to the 25th should be bigger than 25. So I know an answer of 8.8 isn't reasonable. It's going to be 817 blah, 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 with a whole bunch of zeros at the end. All right, so now you can use Theorem 6 to try and identify whether these two statements are true or false. And then you can use your calculator to confirm, see if you did it right. Okay, so that's going to wrap up Chapter 2F for us here. In the next video, we'll start in on Chapter 2G, which is now all about combining these operations and the order of operations together. Looking forward to seeing you then. In the meantime, I hope you have a wonderful day.